Hey, what's going on, everybody? Happy Sunday or Monday, depending on where you are, chat. Hope you guys are doing super good. Man, what a day for spaceflight, might I say, chat. You saw a little bit there of what we're going to be going through today, but SpaceX successfully completed their integrated flight test 5, or just flight test 5, of their Starship super heavy vehicle, and it went almost flawlessly. We'll talk about some of the flaws that reared their ugly heads, as everything usually does at some point within engineering. They, still have some things to work through, but pretty much it's pretty excellent. Anything cool happened today? Nah, intense. It was pretty boring. Yeah, nothing ended up happening. New Shepard scrubbed for today because of GPS issues. Yeah, nothing really happened. Oh man. Yes, the kaboomy landing. Yep, flight termination system did go kablooey. I was actually surprised because I knew that they were going to activate the FTS system, but I was surprised with how quickly they did it. Like if you were watching the live stream that we covered this morning, because I feel like in flight test 4 with Starship, I knew that they were going to do the same thing, but it seemed like flight test 4 Starship, from my memory anyways, was able to stay there for a while. And by a while, I mean, I don't mean, for a very long time, but it just seemed like it was a longer landing or subsequent landing than flight test 5 today. So I was very surprised with how it just tipped over in the water and then, blew up like that. But that was the flight termination system. Yeah. What's up, Dr. Longballs? What a day indeed. Oh, and also Bravo Alpha Echo coming in with the Twitch Prime subscription on the Twitch side to start the stream off. But yes, chat, as we are going to be doing here, we're gonna kick things off with episode 6 of our Go No Go Poll News. That's our name for our space news segment on this stream, and we're gonna recap today's fantastic events. Mainly Starship, pretty much almost entirely Starship, and then we'll cap everything off with some discussion about Europa Clipper, because the Europa Clipper mission by NASA and JPL is set to launch here tomorrow at I believe it's noon Eastern, or just after noon Eastern. So that'll be launching on a Falcon Heavy. So we get to be spoiled by SpaceX a little bit more with another uncommon launch system. Falcon Heavy will be launching another interplanetary mission here starting tomorrow. But what do you guys say we get right on into it with some Go No Go Poll news? Key that transition. There we go. Perfect. Yeah, so today's Go No Go Poll news is pretty light for our Go segment, right? We pretty much have Starship flight test 5, because obviously. We also have the Europa Clipper, and then we'll cap everything off from the Starship news with some SpaceX skeptics, which is kind of hilarious to me. But anyways, yeah, yes, very good day, very good, very little, like no bad news really today, other than I guess I should have added to this. I'll mention it. That New Shepard did scrub today, apparently due to some GPS issues. Probably because this thing was using all of the GPS, Kappa. I'm still in shock from the booster catch. Yeah, yes indeed. Probably from Starship hogging all of the GPS signal. I think that's what it was, right, chat? That's how that works. But yeah, let's go ahead and first kick things over here into our scheduled launches for this upcoming week. So like I said, we have Falcon Heavy, another uncommon launch vehicle that's set to be an excitement with the Europa Clipper mission. That is set to launch here at 10:06 a.m. Mountain Time, so that is noon Eastern Time, flight out of Kennedy for LC-39A. So that should also be a good mission. That is heading to Europa on Jupiter's moon. It's actually, to my knowledge, if I recall correctly, in terms of the mission, it is not actually going to orbit Europa, because the gravity of Jupiter and all that sort of stuff doesn't really make that very good. So it's going to orbit Jupiter, but over a 3-year targeted minimum mission span, they hope to have like 50 flybys, getting within like 16 miles altitude of the surface of Europa, which is pretty awesome. So that Europa Clipper mission is set to launch here tomorrow morning. We also have, of course, Starlink kicking things back off, since we now have some FAA regulations, or licensing has been provided. So they've actually, not the licenses, but they cleared Falcon 9 to launch again. So that's good, the FAA. And then let's see, what else do we have? Oh, that's right. And we also have the H3, not the H2A, the H3, the newest generation of the JAXA launch system, is set to launch, I believe its second mission here on the 26th. So we still got another week away from that. But yeah, for the next little bit, we got SpaceX, chat. Should be pretty good. Europa Clipper has potential for some amazing discoveries. You're not wrong. What's up, Dalek? How are you? They easily caught the booster. Very easily. 100% very easily. Yeah. All right, so let's kick things off, chat, shall we, with the talk of the day. Look at that. So if you guys don't know John Kraus does fantastic work. He is the photographer for all of the fantastic launches that occur from SpaceX. He covered, he was actually part of like the team, if you will, integrated with the last mission for Polaris Dawn. He did like all of the photography from there. John Kraus is the guy. Fantastic images from John Kraus here. This is the liftoff of the Starship Flight Test 5. So you can see Starship here at the top, fully integrated with its SuperHeavy Booster. Launch was magnificent. If you did not see the live stream, we have the entire coverage that we covered. I woke up at 5 a.m. today and covered the launch. So we have all of that stuff on our YouTube channel here as well for VODs. It's also on the Twitch VODs as well if you want to look at it there. But yeah, went off without a hitch. So not only did the launch commence at 7:25 a.m. local time, 6:25 a.m. mountain time, my time, it flew perfectly. All 33 engines on the Super Heavy maintained throughout the entire ascent. We had good engine ignitions during landing. If I recall correctly, I believe all 13 engines in the center during landing burn all went off without a hitch. The boost back burn was perfect. It all looked just mint exact. Like, I don't think it could have gone much better for SpaceX. It really couldn't have, in terms of their objectives, the data that they acquired. They did the entire flight profile without really anything going wrong. There were some funnies, don't worry, chat, there were some funnies that we're gonna talk about here momentarily, but yeah, first try, chat. So there you can see another fantastic image from John Kraus here. Look at that plume in the very early dawn, basically sunrise. It was absolutely on sunrise. The sun wasn't even finished cresting the horizon when it actually separated from the orbital launch mount. But as you can see, 33 good engines, 33 by 33 on the Super Heavy first stage. Trajectory all looked fine. We'll actually even go into somebody who actually went through the numbers and tracked everything through the video and basically compared it to Flight Test 4. Everything went basically exactly as it should have, exactly the same. So the blue lines on the exhaust from the ship cam were so beautiful, weren't they? Yeah, you can start to see them right there. Yep, getting that mixture of the blue, which comes, I believe that comes from some unburnt propellant mixing with the gas and then igniting and then mixing with the oxygen in the air, and so you get basically a leaner cycle, if you will, from the mixture of the oxygen in the atmosphere with the unburnt propellants as it ignites, and so you get that really, really good blue. Yeah, can't touch this. Exactly right. So John Kraus again is the photographer from these pictures. There is Super Heavy on the return, chat. Just look at that. A very, very hot pepperoni pizza on the bottom of this rocket. They did jettison the hot staging ring. We actually got to see that from the ground camera this time. Last time on Flight Test 4, we actually got to see a camera that was basically inside of the what would you call it, the bulkhead or whatever between the hot staging ring and the forward bulkhead of the Methalox tank on Super Heavy. But this time we didn't get that camera angle, but we did get a really good zoomed in camera angle from the ground, and we could actually see not only this but also the hot staging ring separation, which was pretty good. The engine's burning up as it's falling, so weird but cool. Yeah. So if I recall correctly, I believe they had some sort of heat shield material at the bottom, and I believe that's what's on fire here. I'm pretty sure, if I recall correctly, that's what's on fire here. Is the under, you know, wherever this structural mount is for all of these engines, they basically had some sort of fire blanket or some material around the engines to try and, you know, help mitigate any sort of heat, as it not only does its landing burn, where all that exhaust is going to be going up into this cavity here, but also don't want any sort of re-entry heating, because this thing goes fast through the atmosphere, chat. This thing goes very, very fast. But yeah, it gets very toasty, and we actually saw it after landing that the engine section here was very clearly having molten stuff just fall off of it. So yeah, whatever heat shield material they put under here definitely, I guess, did its job, but yeah, a little worse for wears. But yeah, again, Don Kraus photos here, and this was it. This was it, chat. That is Super Heavy in its almost hover. This thing slowed down a lot, and I can only imagine from a guidance, navigation, and control perspective, because this thing has some insane controllability and can throttle down to where it can basically hover. It was able to translate and just get right on cue, right into the catch arms. Who shot those pics again, please? Don Kraus? Yes, Don Kraus. No, John Kraus. Definitely want to give him full credit because he does such a good job. But yeah, look at that shot, chat. Just truly unbelievable. Because remember, ooh, that's a good picture, but that's not what I want at the moment. Where is it? Where is it? Is it this one? No, it's not that one. I know. There's more. There's this one. This is the one I want now, chat, because I want to do a side-by-side comparison. You guys don't remember, this is what SpaceX posted, a render of what it was supposed to look like. What's up, Smoke? How are you doing? This is what we were expecting here. This is what SpaceX official posted. This is a render. Okay, this is not real. Not real life. All right, let's pause it right there. All right, I hope you guys see where I'm going with this. So we're gonna take you and put you over here, get this back up here. And then let me see if I can't. Yep. Maybe go a little bit. No, that's actually pretty good. We're just gonna take you a bit smaller. There we go. And so this is what they wanted us to think about, and then this is what we actually got. I mean, yeah, it's pretty incredible. Pretty incredible. The render was very true to life of what we should have expected to see, and by golly, chat, they absolutely did it. So yeah, landing, of course, first try, might I add you, chat. This was the first catch attempt, and well, it essentially did this right here. What's up, Apollo? How are you doing? Although I do have to say, it didn't quite do that. Well, it actually kind of did. I spoke too soon. I was going to say the render didn't show it getting like super close to the tower on the engine exhaust, but no, it did. That was pretty much exactly what we saw. Uncanny, chat. Just absolutely uncanny. So that's what they were basically expecting, and this is what we got. So this is posted by SpaceX Prime. This was during liftoff You can see all 33 engines, 33 by 33 chat, all is looking good. And then we get this. This was very close to the actual catch attempt. One of the funnies that I'll go ahead and mention here before we actually discuss it, some of the engine bells caved in. Yeah, you can see this one right here. That's flat. That one's a little bit flat. You can notice by the oblong shape, that one's a little bit flat. Let's see, where's the other one? There was actually one that was really pretty bad too. I think it's this one that's kind of covered up by some of the exhaust here, some of the venting. But yeah, the engine bells collapsed a bit. They got heavily warped. Most likely due to the aerodynamic forces, I can only imagine. Not only that, but you can also see that it's missing one of the chines. Chine is a word for basically this shape of a static aerodynamic surface. Yeah, it's missing that chine, most likely also due to aerodynamic loads on the vehicle. But like I said, this is the first catch attempt that they've ever tried, and it went flawlessly. First booster catch and 100% success rate. Yeah, we were talking about the stream. We were talking during the live stream before the actual launch, and NASA Spaceflight did a pretty good analysis on looking back at, I think they said something like 90 flights of Falcon 9 landing on a barge, landing on the drone ship, and the landings out of that pool of 90 or however many they did, I think it was like 84 or something, had a 68% accuracy on hitting the X in the middle of the drone ship. Now you might think that's low, but also keep in mind that they expanded that out to that ring, and 99% of all Falcon 9 landings on drone ships have landed in that circle that we see on the drone ship. And then like I think 95% basically made it way closer than that even. They did like 3 rings. Highly recommend looking at that video. They did a pretty good analysis. And we were talking about it, like, is 68% good enough for a booster catch on the Megzilla arms? And you know what? It seems like, yeah. It seems like that reduced throttle capability, the added controllability that gives them, because they can really slow the vehicle down and basically translate really effectively. Seems like that was pretty much on point. And yeah, Catch Tower did its job very well. Blame it on the weather. Yeah, the drone ships, of course, also are, rolling with the waves, and they have potentially worse atmospheric effects out in the middle of the ocean. But yeah, it couldn't have been a calmer day, that's for sure. If I remember correctly, like today's flight was perfect. Like no low level winds, very, very light upper level winds, like no clouds. Like it was truly a great day to launch this. So, and all of that played a good role in having a very positive outcome for this Flight Test 5. Hey, what's up, Admiral? How are you? The throttle control during the catch was pretty impressive. Yeah, yes, it was. It was very impressive. So that's one camera angle. This is reposted here by Dutch Space, and we have another one here. Check this one out, chat. Look at that. Look at this camera angle. Oh, man. It's so good. And there's sunrise in the background too. It's impressive. What's up, Element? How are you doing? Chopsticks look like computer is making sure they don't squash the booster either. Yeah, for sure. And I'm wondering if the Megzilla catch arms can even squash the booster. I'm sure they have pressure plates, and I wonder if they even have like a mechanical restriction as well, like in terms of the motor actuators, if they can even close in more. But yeah, it definitely did its job. Designed to we actually saw them on NASA Spaceflight 24/7 Starbase doing the I think NSF called them the slap tests. Basically they had the stacked booster on the OLM, and they were taking the catch arms and they were just doing this over and over and over again. That right there, testing how flush they can get them, how quickly, and to make sure that the loads on the vehicle were fine. But yeah, absolutely amazing, right? I've been saying that for years. Every Falcon 9 landing on the drone ship, not only center, but landing legs pointed at the corners of the ship. They've been practicing for a long time. Yeah, 100%. So it looks like Super Heavy has 2 hold down points on for the arms. How difficult is it to control roll so the hold downs end up on the arms? Well, that is partially from the grid fins. The grid fins are designed to maintain its roll stability during entry, and we actually saw it. It looked really, really stable. And then when the engines turned on, you might be able to see it in this angle. It did, do a little bit of this, right? Like swaying back and forth. But then also like Falcon 9, it also has its RCS system as well. But yeah, you can see them right there. There's one hold down point. And then there's one basically 180 degrees offset from that. So yeah, I mean, how good is the roll control? Apparently good enough. Apparently good enough. But yeah, it's definitely designed with a lot of margin of error, if you will, because not only do you have the grid fins to try and help it during fast supersonic entry going through the atmosphere to maintain its roll orientation relative to where the catch arms need to grapple it, but then it also has 3 engines. Well, actually, originally, yeah, it has 3 engines that are part of the final landing burn, and those actually are able to swivel and gimbal to maintain that roll control as well. So yeah, it should be good. Well, but we'll see, right? The next step is repeatability. Although I do wonder how quickly SpaceX will try to go for repeatability when this isn't even going to be the flight system, right? This system right here, this architecture is already obsolete from what SpaceX wants to do. Because remember, SpaceX wants to stretch Starship and Super Heavy, or at least Starship. I think they also want to stretch Super Heavy. Starship is going to get bigger. It's going to have more propellant, so it can actually achieve a viable payload mass to orbit, because right now it certainly can't. And then, of course, they have a lot of design iterations to go through for Booster, who is only on Booster 12 here, that Elon has also said is going to be heavily improved. A big one is going to be the integration of the hot staging ring, changing that up so they don't have to jettison it. There's definitely going to be a lot of changes. So I do wonder how, in terms of like their milestones and objectives, how quick they actually want to get to repeatability. That's of course great, more data, amazing, but they're going to have to redo it anyways for the larger system. But yeah, definitely the more data, the better. I definitely want them to turn around Flight Test 6, because as we talked about earlier, the FAA license for Starship Flight Test 5 apparently covers Flight Test 6 as well. So they already have their launch license for Flight Test 6. So they don't actually have to get FAA approval. Well, I guess they still have to get approval, right? They have to go through the normal regulatory bodies for like setting up the NOTAMs and, the no flight restrictions and stuff like that. But as far as I understand, they already have the actual launch license that covers Flight Test 6. So we could see a very fast turnaround for Flight Test 6. That's all I'm going to say. A lot of deflection on the chopsticks, though, when it makes contact. Yeah, it certainly does. But there's actually a lip on these rails. Actually, you know what? Let me just do this, right? I think it's this one. Oh, there you go. This is posted here from Jenny H Photos. Really great view. You can actually see, so this is the grid fin. You can tell it's a grid fin by the way that it is. And there's that hold down point, or that structural load point for the catch arms and the booster integration. See that? And there's actually a lip, a really sturdy lip on the edge of this system, and it's also on a track with a gigantic worm gear, so that way they can move it forward and back as well. Or actually, even like a tank, they can move them separately, so you can get the booster flush, or not flush, but like, along the axis that it needs to integrate with the orbital launch mount. It's a really cool system. But yeah, it certainly does flex, but it's not like, it shouldn't just flex so much that it's going to cause this thing to fall off, right? They do have some things implemented engineering wise, structural wise, to help mitigate that. Is it possible that the Starship exploded because the Starship is hot and the sea is cold? So they terminated it. Cian or Sean is Cian? Yeah, Cian. They terminated. They hit the flight termination system during the live stream. I was just surprised by how quickly they did that, because it like just landed. We panned away to the buoy and then it exploded. So I definitely thought it was because when it hit the ocean falling over, it looked like it hit the ocean pretty hard, and I thought something cracked and explosion. We've seen that happen numerous times with Falcon 9 on drone ship landings, so I kind of thought that was the thing, but apparently the flight termination system was triggered. And they do that for reasons to protect their IP and to protect the United States with respect to ITAR regulations, and to protect themselves via ITAR regulations. They don't want anybody out there on a boat being able to get to it before they can, so they sink it. They're not going to recover it. They don't need it. So yeah, they confirmed it was the FTS. I'm pretty sure, like, it was always within their plans to do the FTS. I don't know if they confirmed that it specifically was the FTS, but that is my understanding that it was. I mean, I knew that that was the whole plan. The whole plan was to terminate it with the FTS system. They weren't going out there. They had nobody in the area, no boats, so it was going to be terminated via a fun explosion. But yeah, I was surprised that it happened so quickly. Maybe vessels were in the area? Maybe. I don't know. I don't know. But yeah. How do you make a top-mounted Mark II shuttle with super heavy bottom boosters? How do you make a top-mounted shuttle? Ooh, so you're gonna be looking at something similar to Shuttle Saturn, Andy. This is what you are probably getting at. Yeah, this was a real-life concept, by the way, chat. So if you don't know it, back when they were looking at oh yeah, Hayes Gray Art. If you guys don't know Hayes Gray Art, right? He's a fantastic renderer of all things space concepts. Literally took a gigantic Saturn V first stage and then integrated the shuttle stack on top of it. Therefore, we have Saturn Shuttle. Oh yeah, and the actual Saturn V first stage was designed to be a flyback booster as well, because NASA was crazy back in the 70s. But yeah, this is what you want. Something like this is what you want. Hey, what's up, Captain Failure? What do you think happened with the FAA? It was late November and said no launch license a day or two before launch by one of their representatives. I don't know. I think they had some external pressures. You know, I kind of think it's a little unfair, the whole thing with the FAA. That's kind of my take. I think both SpaceX and the FAA are in the wrong. You know, you can call that a floppy viewpoint if you want, but like, SpaceX clearly violated their launch license, or at least it kind of seems like they clearly did, in accordance to the FAA. But also the FAA is very slow for what SpaceX wants to do, and they have to get their stuff in gear. But also at the same time, the FAA already has things in place to make the licensing process go faster, as implemented starting back in 2020. And SpaceX isn't taking advantage of that yet, because they have to, you know, it's a whole new licensing process. But, you know, that whole stuff is, yeah, it's weird, honestly. It's weird. Artemis before Artemis. Yeah, exactly. FAA sounded like they wanted to remove a problem that was happening at a bad time. Yeah, I can get that for sure. Yeah, it depends. Exactly. Yeah, it depends. But anyways, getting back to a chat, fantastic catch attempt on the tower as well. So good. This was also released by SpaceX. So this is what I was going to talk about, chat. So this is what it looked like during takeoff, during the actual launch separation. This is from the orbital launch mount. Or, I'm sorry, this is from the tower, looking up at the 33 successfully ignited engines on Super Heavy. And then this is what it looks like on the return. So it looks great, right? It looks fantastic. But you notice something here, chat? That engine bell is not a bell shape anymore, nor is that one. You can tell it's not a bell by the way that it is. It looks more triangular. Same with that one. This one looks really crumpled in right here. This one on the back side here looks like it's crumpled. Yeah, this one is also all kinds of messed up. Like, look at that. It's all kinds of messed up. So this was one of the funnies. That's certainly a bit of deformation. Yeah, 100%. Very, very much warped during the entry process, I can only assume, because we can actually calculate it, because this would be primarily due to the drag force on the vehicle. and drag. Hold up, chat. Hold the phone. Hold the phone. You know what? We gotta get paint out. I'm sorry for the flashbang. Oh god, that's orange. No, I don't want that. Have it. Here we go. So we know that the drag force is going to be equivalent to QV infinity squared times the coefficient of drag times the area of the forebody of the vehicle. Q is dynamic pressure, and that's going to be 1/2 rho V infinity squared. Actually, it's typically just QCDA is what it's called, because Q incorporates the V infinity squared. V infinity squared is your velocity. V infinity squared is your velocity. So we need to figure out what CD and A is. Well, CD, if we just kind of simplify this for a cylinder, if I'm going off of memory correctly, I believe is 0.84 for a cylinder. And then area is going to be pi r squared if we talk about just the forebody, right? Just the engine section moving through the atmosphere. It's not going to be perfect, but I think it might be close enough here to give us a ballpark. So that's going to be pi times, it's a 9-meter diameter core on Super Heavy. So that's going to be 4.5 to get the radius, and we're going to square that. So if we want to talk about the maximum force for drag, then that's going to be the maximum V infinity squared. So the maximum velocity at the lowest altitude, essentially. So let's just call this 1, because basically at sea level, your atmospheric density is 1.225, if my memory serves correctly. And so if we say that it was breaking the sound barrier at, I don't know, 10,000 feet, 8,000 feet, something like that off of the ground, then, you know, having a slightly lower atmospheric density around 1, I think should be fine. And then V infinity square, we know at sea level, that's going to be breaking the sound barrier at 343 meters per second. So we can do that. So then our force of drag is going to be equivalent to 1/2 times 1 times 343 squared times 0.84 times 3.14159 times 4.5 squared. Is that right, chat? I think that's right. No regenerative cooling on reentry. No. Not on those engines, because they never ignite again. So let's figure this out. So that's going to be 0.5 times 1 times 343 meters per second squared. Square that. And then we're going to multiply by 0.84. And then we're going to multiply that by pi. So I got my handy dandy calculator out, by the way. And then we're going to multiply that by 4.5 squizzled. I think that's right. Pi 3.14159 4.5 squared. I think that's right. So that is 31. Let's see, what is that? That's 331,430. Okay, let's plug that in. Let's see, what is that? That is 3143492 pascals, and we want to put that into like PSI. So they were saying roughly 450 pounds per square inch on the engine bells, at least assuming these numbers are even remotely correct. That's a lot. that's a good amount of pressure on the outside of the engine bells pushing in. Yeah, okay. And if we can get more accurate numbers, then that only improves that estimation. Needless to say, they got deformed, chat, okay? They got heavily deformed. That is one of the funnies. Let's call it funnies, right? That's a NASA term. That was one of the funnies that occurred during this catch attempt. The other funny that occurred is on the other side here. Looks like this. So this is coming from Interstellar Gateway. So yeah, some of the aerodynamic parts of booster ceased to be integrated with the booster. I think that's the best way to say it. We've got an I2 whiteboard session. Yeah, you know it. You know it. Is there a reason why they don't do SSRP with the booster as they do with Falcon 9s? To my understanding, I think it's because it has a fairly large cross section, so it creates a lot of drag, so it actually might not necessarily need it. It also doesn't go as high as Falcon 9. Right, Falcon 9 during separation on most missions that do the parabolic arc and things like that, it goes up like above 116 kilometers, and I don't believe Super Heavy got that high with Starship. So it just doesn't necessarily need it. It's also made out of steel, which is much sturdier than aluminum like Falcon 9. So that also steel has a much better heat resistance for the lower atmospheric entry that it might see. So it just really doesn't need it, right? The whole reason why they do SSRP, or supersonic retropropulsion, is because Falcon 9 would just burn up, right? That aluminum has a very low melting point. Their stainless steel alloy has a much higher melting point. It doesn't go as high as Falcon 9, right? It just doesn't need that for survivability like Falcon 9 does. Falcon 9 literally does it so that way it can, shoot through its own gas of exhaust plume, because that ends up being colder than the plasma. But I don't think that necessarily has to happen here for booster Super Heavy. But yeah, great question. Yeah, that would be my intuition, let's say, as to why they don't have to do that. Yeah, Warlock, exactly, 100%. Remember not that long ago when people thought Super Heavy wouldn't work because it had a lot of engines since the N1 didn't? Yep. I mean, it's still honestly a valid point, right? They're getting better. 33 by 33 on the first stage, all the way through flight and everything like that. But it took them 4 flights to get there, right? Before we stopped seeing Raptor reliability being any sort of issue. Didn't Flight 4 actually have one Raptor go out? This was like the first actual perfect Raptor system, or Raptor debut, if you will. But yeah, so it's still valid, although we definitely are not seeing turbo pump failure, at least explicitly. But that's also because if we go back to here, each one of these engines is housed in its own vault, its own bunker. In order to completely separate the turbo machinery from the rest of the engines around it. So even if one of them was to pop internally, it's supposed to be completely shielded from everything else. So, maybe because we have seen on Flight Test 4, actually, one of the engines did pop, I believe. It was either an engine pop. No, I believe it was an engine pop during the actual landing burn. And it just had a big, conflagration event, basically just a bunch of low velocity flames shoot up the side of the rocket because of the methane that was leaking out at that point. But yeah, we're not seeing the fantastic catastrophic failure that N1 had, that's for sure. Yeah, 1 on Ascent and 5 or 6 on the booster splashdown, I believe, for IFT4. Was it that bad? I don't remember it being that bad, but it could have been, yeah. How much mass could they save if not needing so much shielding for Super Heavy Raptors? How much mass could they save? Probably a non-negligible amount, but also probably not as much as the possibility of having a catastrophic failure. Right, it's that balance. They're still making it, I believe, all of these housing sections out of steel. You can see them here on the outside sections. You have 33 of them fully encased in these bunkers, if you will. So yeah, it would definitely save you several tons of material, absolutely. But in the grand scheme of things, that versus the risk of not having it, probably there's probably a crossover on when it's worth it or not. Exactly as much as is needed. Yeah, it depends, as we were saying earlier. I think the biggest difference is 50 years of technology development. Oh yeah, 100%. I mean, these Raptors are, yeah, 100%. Material science wise are, yeah, way, yeah, like you said, 50 years of material science to advance all the turboprop machinery and stuff. And not only that, but they also have essentially 23 years of experience in developing their own engines. They know. SpaceX knows how to develop an engine, okay? They started with the Merlin 1, going all the way into the much larger system for the Merlin 1D engine that they have now on Falcon 9, to the vacuum version variants of it, to now Raptor, and 3 iterations, 3 different families of Raptor engines. They know how to build them. Yeah. Can't wait for Raptors 3. Yeah. That's going to be huge, Chad, because we were talking about that when Raptor 3 came out to debut and how clean and slick it looks. When we got the specifications of what Raptor 3 can do, I don't remember exactly off the top of my head, but it is a unreal difference in just the thrust to weight ratio that each engine has in comparison to just even generation 2. Like, I'm throwing numbers out because I don't exactly remember, but it was like generation 2 could do like 230, it had like a thrust to weight ratio per engine of like 230, but like Raptor 3 was like 350. It was like it was an insane amount of thrust to weight ratio improvement. Yeah, so Raptor 3 is going to be it's going to be pretty awesome. So yeah, we covered that. We had some aerodynamic parts of the vehicle come off. Again, this is coming here from Interstellar Gateway. Let's actually take a gander at this. Yeah, you can see the stainless steel chines, as they're called, these aerodynamic static structures. They basically cover up the COPVs that you see here, but then also they cover up some of the wiring that is used for avionics down to the engine's control and things like that. So you can see the wiring here, and you can see one of the COPVs. They have COPVs all the way up. And yeah, look at that steel just get peeled back. Again, from some pretty hefty aerodynamic loads for sure. Just ripping that up from its integration points. So yeah, another little funny happening on the booster system today. But regardless of all of that, we can't forget this. This is coming from Jay, who is in fact a Starship engineer, as per his bio here on X. I know booster landing was the main event, but a massive shout out to the Heat Shield team on Starship. When they asked us to swap the assembly after Flight 4, it felt impossible. Thousands of hours of work later, we made it an on-target entry. So proud of the team for the monumental effort. So yeah, if you guys don't know, one of the improvements, and we talked about this actually during the live stream, one of the improvements or differences between Flight Test 4 Starship and Flight Test 5 Starship, after they saw the flap get completely destroyed, the forward flap on Starship Flight Test 4, SpaceX had an immediate design change carried out for the heat shield materials, or for the heat shield configuration on those forward flaps. They completely stripped off all of the tiles on the vehicle, to my understanding, all of them, not just the flaps, but all of them. And then they replaced for the flaps so you had like the white Nomex like fire blanket, and then you had a new ablative insulation blanket, and then you also had the tiles. So they added that ablative material somewhere in between, and then completely reconfigured the entire tiles of the entire spacecraft. In between Flight Test 4 and Flight Test 5, let me remind you that Flight Test 4 was June 6th. So yeah, a very, very fast turnaround on the entire redo of the Starship heat shield system. But yeah, pretty awesome, pretty crazy. Very limited burn through. Yes, that is important to note though. Another little funny that did happen was we did in fact get burn through again on one of the forward flaps of Starship. It was right at the joint, which honestly may have saved the vehicle, and then also occurred very late through reentry, way past its what they were calling out for metrics, the peak heat rate. It was way past that flight regime, if you will, and it happened in the very middle, very near the actuator. And I was very worried that because it was close to the actuator, that would be really bad. But it also may have been good that it happened in the middle, because unlike Flight Test 4, where you had that flap burn through happen at the very back, and then it could just eat its way forward, when you have it in the middle of the vehicle, the boundary layer relative to the entire body of your spacecraft may have been able to push a significant portion of the heat away from where that burn through was happening, as if it instead of it being on the edge like it was in flight test 4. So definitely some really interesting like heat dynamics that were going on, but also, like I said, it happened way later in its flight profile than flight test 4, and so that's good. It's saved. It was saved, chat. Got the link for the pic with the deformed engine bells. I sure do. I think this is coming from SpaceX, but there it is, zoomed in, the actual system. The pivot mechanism is a huge heat sink compared to the skin, so harder to melt that. Yeah, could have been. Could have been 100%. Drop the phone. There we go. As Scott Manley said, it's not about how hot it is, it's about how much hot there is, quantity over quality. So you should be caring about max drag instead of max temp. Yes, you definitely got to care about both peak heat rate, and then you have to care about integrated heat load, because that's how much heat is soaking into your vehicle over the entire time of entry. Peak heat rate is basically the highest point of heat flux instantaneously going at some point in your vehicle. And then you have your max Q going through entry as well, where the aerodynamic forces are then there to separate your vehicle if you need it, or if if it happens. So yeah, lots of things happening over time for sure. Plus, forward flaps are redesigned for next iteration, so they won't be in the flow. Yep. Like I said, Starship 2.0 is essentially right around the corner. This architecture is obsolete from what SpaceX is already planning, because Starship 2 is going to be stretched in terms of its propellant tank loads. It's going to have redesigned flaps. It's going to be a new vehicle. They're going to have to test it all over again, but they have qualified certain aspects of this vehicle which will carry over. Remember Atlas 5 with Vulcan, and how Atlas 5 was used by ULA to basically certify a bunch of the parts that are going into Vulcan? Same exact concept, chat. So it should be good. Should be good. Anyways, moving right along, chat. We had this fantastic picture as well. So it wasn't this flap, it was actually the one on the other side, but right here. Not so much here, and not so much here, but right here was where we started to see burn through, but it was very, very minimal. Again, like I said, it started to happen way late in through the re-entry profile. The actual trajectory it was taken through the atmosphere. It happened way after the peak heat rate performance metric. And so, yeah, we did see some burn through, but nowhere near as much as what we were seeing back on flight test 4, which is really good. Tommy Boy reference, you know it. You know it. More testing equals more launches. Oh no, poor space nerds. Yeah, I know, right? Yeah, more 5 a.m. launches for me, I guess. Sorry, but V2 being larger, is it good or bad from a TPS point of view? Version 2 being larger, is it good or bad from a TPS point of view? It's a trade-off, Captain Failure, right? Because it's good because when you have a larger vehicle, depending on its mass fraction change, and usually when you scale systems, your mass doesn't necessarily scale as fast as your volume. So, even though you're scaling it and stretching it, you actually might not necessarily get a big impact on your mass increase versus the amount of volume that you increase per unit that you stretch it. So if that's the case, then you actually lower your ballistic coefficient, which is fantastic for a thermal protection standpoint, because now with a lower ballistic coefficient, you slow down faster in the upper atmosphere. You typically have lower heating and things like that. But then also from the other standpoint, if you have a larger vehicle, then you need more tiles to cover it in certain areas. So it's a trade-off. It is certainly a trade-off. But generally speaking, going larger, so long as you keep the mass from exploding and increasing beyond, because there is a crossover point, right? If you increase your system and mass goes up more or at the same amount as your volume, then you're not really getting any benefits of a larger system. The increased drag that you might get from that because your mass is still increasing a lot. But if you can stretch it to the point where your mass isn't increasing nearly as much as your overall drag area is, then your ballistic coefficient goes down, and that's better for your overall heat metrics. All right, chat. Moving right along. So that was, of course, Starship had a fantastic flight all the way down.
Landing bird startup.
And if I may, this is what we got to see, chat, right? So this is Starship landing. It landed. Everything seemed to survive. And we'll get into the actual numbers here in a second. Flight Test 5 Starship had a better landing than Flight Test 4. For obvious reasons, because Flight Test 4 had the floppy flap after it had that burn through. And the numbers do indicate that, which is pretty cool.
Landing bird startup.
Buoy camera was unreal. What's the smallest rocket that's made it to orbit? Probably a... that's a good question, actually. Look at that. So it's in the water here. Notice how it's basically stable attitude. Now it's tipping over into the water.
Landing bird startup.
Oh, they don't show it. They don't show it. SpaceX, how do you not show it in this recap here? Well, after that, definitely. Does anybody have it here? I can't believe they don't show it, chat. That's crazy. How do they cut it off there? Wait, is it this one? How dare they? There we go. Here we go. Yes, thank you. There we go. You know the highlights in the water, or the lighting in the water? Yeah, it's pretty good. A longer buoy footage would be nice. Yeah, I'm hoping they release that too. So there it is. It's in the water at this point. We have flame out of the engines, that big rush of flames. And now it's tipping over into the water. Impact with the water. And now it's on its belly. And then flight termination system ignited. And from what I can tell from here is that I believe Starship was cut in half. Because if this camera angle, it's hard to see it because lighting is not good, right? But if I am looking at this correctly, the engine sections were it was basically going this way with the nose in this direction, the engine section in this direction. If this was, in fact, you see where the fire is here? That should be the engine section. And if I am correct in that assumption, then here you can see that same engine section or whatever. You have a part here and you have a part here. Yeah, so based on that, assuming that the orientation and everything was correct, like I said, lighting is hard to tell in the grainy footage as well. I'm pretty sure it got cut in half. Based on that assumption. But yeah, pretty intense, chat. That was the flight termination system. Chat GPT says smallest rocket made to orbit is Electron. That's what I would have guessed, because I was going to say Astra, but Astra didn't actually ever achieve orbit, sadly. Well, actually, did they? Maybe Astra, because isn't Astra lighter than Electron? And I thought Astra actually did achieve orbit. They just didn't achieve their desired orbit. I'd have to go into that one. Didn't Astra's rocket, like Flight 7 or 8, actually achieve orbit, but they didn't have enough propellant to achieve their desired orbit? Or did it always stay suborbital? That would be my my one stipulation that I have to look into. Yeah. What about Virgin Orbit? I think Virgin Orbit's actually bigger, believe it or not, stealthy. But yeah, I'm not 100% certain on that. But yeah, chat, absolutely crazy flight of Starship in the water. Second time, chat. This is repeatability, right? This is the repeatability, which is amazing to see. You can see it's coming in because it does that flip maneuver, and you basically go into that belly flop, and then they ignite the engines when they're in this belly flop configuration. So it actually translates forward, and the engines that are ignited actually pitch up, right? They gimbal up to help it actually swivel in for landing configuration. So you can actually see it here. When it flips over to the other one, it still has some of that velocity kind of like swinging around as it's going in for a landing. But it has some of that horizontal velocity component. and then it just sets down nice and easy in the water. We have engine shutdown right there. We have the big belch of methane coming out during shutdown, and then it tips over, and there you go. Drink. Keeping me hydrated. Fantastic day indeed. Yep. All right. Keep moving along here, chat, because we are almost done, but not done yet. So, like I said, this is coming from Max. Max is an aerospace engineer, works at Blue Origin and things like that. He, at least I assume it was him, actually took the telemetry from the video from Flight Test 5 and compared it to the telemetry that we got from Flight Test 4. And yeah, let's take a gander at this. So you can see here for Flight Test 4 and Flight Test 5, almost the exact same, right? Altitude all the way going up to let's see, peak temperature, peak heating. We have flaps have control, so we have velocity going down. So this is going through entry, by the way, chat, right? Going through entry. So this is coming in from 160 kilometers, staying at a pretty constant velocity. Basically, it's orbital velocity, right? And then it starts to hit the atmosphere and really starts to slow down. Let's see here. We have the first plasma there. Wow, this is actually excellent. I didn't get a chance to review this fully beforehand. So Mach 18, 16, 9. So max Q occurs at 7. Peak heating occurs way back here at 7 kilometers per second, which is pretty crazy. We had our peak temperature where we actually got to see some of the, I think the burn through happened somewhere down here because it was way past peak temperature and peak heating, but I believe it was before max Q. So it happened somewhere in this vicinity between Mach 16 and Mach 9. But as you can see, basically going all the way down, it's almost exactly IFT 5 over the top of IFT 4. You can actually see a very slight deviation here in this bump. And another one here at this bump, but for the most part, the entire system all the way down is the exact same, which is absolutely crazy. So that's great. That's good to know that the vehicle has repeatable dynamics, you know, no weird things. And then this is awesome. So then he kind of zooms in on the different, or he does it with respect to time, right? So this is what we see, velocity versus altitude remaining relatively the same. But now we have time to splashdown versus altitude. And so we can see here, which is pretty awesome, there's a clear deviation between Flight Test 4 and Flight Test 5. Two guesses as to why there is that deviation. I already said it earlier, but it's actually really cool to see here in the data. Looks like SS-520 with a payload to LEO for 4K. Oh, small lift launch vehicle? Well, that's interesting. Huh. Well, there you go. Oh, well, we got to get to that here momentarily. Seemed like there's a non-zero chance Starship is now catchable for a tower. Yeah, 100%. I do wonder when exactly they are going to try and attempt a catch attempt for Starship. Because arguably speaking, they don't actually have to do it except for the funsies and the data until they get Starship 2 open, because Starship 2 is going to hopefully fly the same, but it's going to be stretched and it's going to be bigger, and you know, things are going to change dynamically. So do they go ahead and try to go for a catch attempt on Starship when it's not going to be the same vehicle? I don't know. I can see it kind of going both ways from like an engineering standpoint. Yes, it'd be great to have that data, but also like to get the regulatory approval for that, for Starship to actually come back from orbit and land, especially when they're still having issues with like the heat shield. Like, do you get the heat shield like buttoned up perfect now? Do you just wait until ship 2.0 because that's going to be down the road and it's going to have different systems and upgrades and whatnot? I kind of see it going both ways. They could just do it because they have the they have no shortage of Starship prototypes at the moment. We're obviously going to get Flight Test 6 with I think still a Gen 1 or like a Gen 1.5, if you will, Starship. So arguably, yes, they could if they get the regulatory approval, but I also don't know if it's necessarily required. It'd be good to have, but yeah, in terms of your roadmap, yeah, I don't know. So it'll be a fairly big coding change for Martian conditions in regards to landing. No, No, it shouldn't really be that big of a coding change. I mean, it will definitely be a coding change, but you can still basically go off of, you know, velocity, and your velocity versus altitude is a very rough metric. I mean, you know, these things have typically pre-programmed flight controls and conditions that they have to meet to hit different mile markers in their trajectory. And not only that, but, you know, they have a bunch of simulations. So I don't think it'll be like, it won't be like a complete overhaul, right? If you think of like the flight avionics of Starship as like a library, they have all of the library functions developed, and now they just have to, you know, use that function, pull it into their Martian trajectory profile, and then just feed it the different parameters that the vehicle should look for. So I don't think it would, that would be really bad if you had to completely redo your code for different atmospheric effects, because that would be such a major like certification and qualification process to do that. You still have to test it, of course, before you send humans and whatnot, but I'm just saying, like, you wouldn't like just completely redo the flight systems for that. At least that's how I would think about it. Coming from my background, that would not be how I would want to approach that at all. Yes, use the V1 landing to open up V2 flight path. So could certainly do it. Get that regulatory process underway for Starship 1, so that way you can do it for Starship 2 and already have that data. That'd be certainly pretty awesome. I just don't know. I don't know, right? Were you going crazy with SuperHeavy was caught? Of course. Yeah, of course. Yeah, you can see the live stream on YouTube, or the VOD on Twitch. Yeah, absolutely, 100%. But yeah, so there's a clear deviation between flight test 4 and flight test 5 that starts to occur, you know, 5 to 10 minutes before splashdown. That's because of the burn through on IFT4 on the flap. You know, Starship lost like a third of the forward flap. And that stuff is used for as like an air brake, if you will, to slow down booster as it goes into its belly flop configuration. And when you're missing a third of that, yeah, it's not great, right? It's not great. And we get to see that even more in this one, where we have velocity versus time to splashdown, a very clear difference as well. IFT5 started slowing down way sooner than IFT4 Starship, which is very, very telling, right? But yeah, this is what I just thought was super, super cool to actually see here from Max, because you can actually see from the data and what the data says regarding the flight profile between IFT4 and IFT5. So if they now do an IFT6 and we get the same data and it looks exactly like this, ooh, that's going to be good, Chad. That's going to be great data, good repeatability, good controllability of your vehicle. It's going to be good. It's going to be good if that's true. I'm still impressed the avionics were able to handle that much flap missing on IFT4. Yeah, for sure. Yep, 100%. It did its job very, very well for IFT4. All right, chat, moving right along here. I believe this is the last little bit. We actually have to get to our no-go news, which is our SpaceX skeptics. I only have one. I just came across this on my feed and I thought it was kind of funny. If you guys know on X, a guy named CS Skeptic. Yeah, CS Skeptic. This is what Common Sense Skeptic has to say. So takeaway from the Starship launch. Clean launch, clean separation. Fuel mix a little off, maybe. Booster caught by tower, well done, but it was on fire, similar to S10 without the kaboom. Starship landed upright with fins on fire last time, leading edges and hinge points catching too much heat. Did not achieve an orbit yet after 5 launches, did not carry any payload whatsoever, so a long way to go. Oh, man. Goodness. I just, like I said, had a little bit of a laugh when I saw this one, and, you know, SpaceX is going to have its haters. SpaceX is also going to have its fanboys. I definitely am not a quote-unquote SpaceX fanboy, but I can also look at today objectively and say that this is not hitting the mark. This is not hitting the mark at all. What's up, Naps? How are you? Missed your earlier stream. Thought you would be offline tonight. Good to see you. I am back. How are you, Naps? Yes. Debbie Downer indeed. Still clueless. Yeah, still doesn't have common sense, but that's fine. I guess that's why he's skeptical of common sense, right? Those are certainly words, yeah. How do you find ore deposits in Kerbal Space Program? Ooh, you need a resource scanner. One of those big dish in the, I believe it's in the science tab, one of those big dishes, I think is called like resource scanner or something like that, resource surveying scanner. And you have to put it into a polar orbit around the planetary body you want to find ore around. Yep. Are you playing Kerbal today? Maybe, we'll see. Because we are almost done here, but I don't know how long it's going to take to get through some of the Europa stuff. Did they do any on-orbit refueling transfer this time? No, not this time, as far as I'm aware. I'm kind of scared for V1 Starship if there was never any versions after that reaching orbit with basically 1% fuel left. Yeah, exactly, Correctonics. Like, that would be really bad, actually. Yeah, like we've talked about, the current Starship design cannot make it to Mars, cannot make it to the moon, can barely make it to orbit with any payload capacity. They have to stretch it. They have to do something here for version 2. They have to find ways to lighten it, increase its propellant mass fraction, improve its thrust to weight ratio on booster, super heavy, improve the staging velocity that super heavy can achieve with Starship on top, things of that nature. They have to do something, and they're certainly going to. Did New Shepard launch today? No, New Shepard did scrub. That was also a I should have added it here. I'll mention it though. New Shepard scrub because they had GPS issues on the vehicle, which is interesting. Is it worth doing orbit refueling in KSP? I think it is, yeah, 100%. It kind of depends on your architecture you want to go with, because you can certainly do pretty much anything in KSP without refueling. But just like in real life, refueling helps you not have to build outrageously large systems, right? 6 RVACs will solve everything. Yeah, just add another, yeah. You have no more room, so you're saying it needs to go bigger, Joe, right? Because it currently doesn't have the room for 6 RVACs, so it needs to get bigger. Yeah, it needs to get bigger. It's still very much flight test for now, not commercial operations. 100%, yeah, 100%. But yeah, saw this skeptic of common sense and decided to have a little bit of laugh because I don't know how or why he would even say this. The fuel mix is a little off. Like, how could you tell? Are you saying the fuel mixture's off of the entire flight? Is it because you were looking at the relative levels between fuel and oxidizer in the system when the Starship actually took off with different levels of fuel and oxidizer? Don't really know what he's meaning by that. If he's just talking about the percentage, like if you look at the HUD back on the live stream, right? Like Booster had the liquid oxidizer and liquid methane fuel levels, and they didn't line up perfectly. They were slightly off. So if he's talking about that, but I'm pretty sure I remember looking at during the live stream, during the entire pre-stream of everything, where they were actually showing the overlays of the propellant fueling process, the propellant filling process, the numbers were never exact, even at the time of launch. So I don't think it ever got to fully full capacity on both ends. Yeah, leading edges and hit points are a problem. That's fine, but just too much. It just did not hit the mark, okay, on this skeptic of SpaceX. All right, chat, let's switch gears here and get back to our go, no go. We have our go news now as well. So let's get back to it, shall we, chat? It sounds like a LLM hallucinating, trying to sound feasible, but what it's been told to post about. Yeah, it tasted funny, exactly, 100%. Armchair engineers. Yeah, I'm not sure. Definitely, so common sense skeptic of common sense, right? Has a number of these weird takes on SpaceX. Like I said, you don't have to be a fanboy to objectively look at today and say, wow, this absolutely today created history. SpaceX hit all of their objectives, as we talked about here throughout the entire day. Yes, there were funnies that occurred along the way. We had engine bells, collapsing, engine bells being fully deformed. That's not great. You had chines, actual aerodynamic parts of your vehicle completely ripped off of the actual super heavy structure. Yeah, not great. But like I said, did not hit the mark, chat. Did not hit the mark. It's probably a bit, probably. All right, chat, let's switch gears here a little bit and let's talk this. So, NASA Launch Services Program. Launch update. NASA's Europa Clipper is now targeting Monday, October 14th for launch. It's an all clear after the storm, moving forward with preparations for the mission. So look at this, chat. So this is encapsulation. This is Europa Clipper. Each one of these solar arrays, when they're deployed, is going to be over 100 feet long, 30 meters total for both wings. It's very large, chat. This system is designed to orbit Jupiter and do flybys. I think like 50 flybys of Europa, one of the moons of Jupiter. Basically one of the large, possibly underground or under ice oceans faring celestial bodies, which is really cool in our solar system. It's going to have ice penetrating radar, getting really, really close, up to like 16 miles altitude, which is nothing. It's getting very, very close to Europa. This is going to be an awesome mission. It'd be funny if Skeptic actually worked for SpaceX. It would. You're not wrong. That would actually be funny. Plot twist. But yeah, they had a pre-flight announcement. Oh, and did I mention, chat? It's launching on Falcon Heavy. Yeah, SpaceX is giving us another treat. 2 treats in 2 days, where we see another uncommon launch configuration for SpaceX. So this is Falcon Heavy, and what's awesome, chat, is that these 2 side boosters flew the Psyche mission. The asteroid mission, yeah. Same boosters that flew mission to Psyche launched last year. So pretty awesome mission, pretty awesome flight stack here. RTLS landings. Of course, I believe we're losing the center core stage, as we do with all Falcon 9, Falcon Heavy launches. But yeah, we're sending a vehicle into deep space to orbit Jupiter. Don't forget to carry the 1 on those Europa orbit calculations. Yeah, we don't talk about that. But anyways, chat, I thought we'd give a little bit of a listen to today's press conference and see really what came out of it. See what questions came out of it. See if we can't learn a little bit more about the mission itself and all that jazz. So go ahead and pause the music, and we're just going to chill and see what we can learn. Hello, NASA.
You are live.
There we go. We are live, chat.
Good afternoon. I'm NASA's Megan Cruz.
Do they replace the nose on every launch? That's a good question. I don't remember.
Teleconference.
I don't know.
Europa Clipper is a 5 and that could have the ingredients for life. NASA just wrapped up a successful launch readiness review, so we are marching towards a launch attempt tomorrow, October 14th, for liftoff at 12:06 p.m. Eastern Time from Launch Complex 39A. And to tell you more about today's review, we have here in the room at Kennedy Space Center, NASA Associate Administrator Jim Free. Sandra Connolly, Deputy Associate Administrator, Science Mission Director at NASA Headquarters. Jordan Evans, Project Manager of Europa Clipper at NASA JPL.
JPL, yep. JPL is running it.
Launch Director, NASA's Launch Services Program. Juliana Scheinman, Director, NASA's Science Missions at SpaceX. And Mike McAleenan, Launch Weather Officer, 45th Weather Squadron at the U.S. Space Force. Okay, so each has some opening remarks, and then we'll start taking questions from the phone. For those on the line, press star 1 to get into the question queue and star 2 to get out. All right, Jim, go ahead.
Thanks, Megan, and good afternoon. Thank you all for dialing in today. I first want to take a minute and acknowledge everyone who's been affected by both Helene and Milton. It's
by the way, this occurred earlier today at like 4 p.m. Eastern, if I'm not mistaken.
The launch of Crew 9, and the safety of our workforce
so it was just a few hours ago.
Is certainly our top priority, and the Kennedy Space Center team, led by Janet Petro, has done a tremendous job at looking out for people and getting everything back online here so we can hopefully launch
I think so, Descom. I think it would.
The SpaceX and NASA teams did a great job keeping the hardware safe during the hurricane. And
we'll get there, Burninator. Don't you worry.
Tomorrow as we send the spacecraft on its way and hopefully bring home Crew 8 later this week, assuming we get the weather to cooperate.
Yeah, I didn't mention that, but Crew 8 was supposed to come home today, and then they had to scrub it.
Explore the unknown in air and space. And this mission is really the perfect example of exploring the unknown in space. Europa is a fascinating destination. At NASA, we strive every day to answer fundamental questions about our solar system and our place in it, and Europa Clipper will help us answer these questions. Clipper is the first NASA spacecraft dedicated to studying an ocean world beyond Earth. It aims to find out if this icy moon of Jupiter, called Europa, could have conditions suitable for life.
It's got under the ice there's oceans, which is pretty awesome.
Clipper has
Or
some
at least it's
remarkable
theorized.
innovations, from its massive solar arrays and radar antennas to the radiation protection that's been engineered for the spacecraft, all of which Sandra Conley will tell you about in just a minute. And the last part of the NASA mission statement is to inspire the world through discovery. Beyond Earth, Jupiter's moon Europa is considered one of the most promising habitable environments in the solar system. While we're not going to search for other life, Europa could have all the ingredients for life as we know it: water, organics, chemical energy, and stability. What we discover at Europa will have profound implications for the study of astrobiology and how we view our place in the universe. And I want to thank all the team that has worked so hard and their families that supported them along the way.
Nice.
Let me turn over to Sandra Conley, who's the Deputy Associate Administrator for the Science Mission Directorate.
So yeah, now we should learn about the science that they're actually going to conduct here now.
Thank you, Administrator Free. As the Administrator said, I am the Deputy Associate Administrator for Science, and I cannot be more delighted to be here to speak to you about this really exciting mission. At NASA, science enables exploration, and exploration enables science. I am super excited for the launch of Europa Clipper. Europa Clipper is a very important part of our Science Mission Directorate's portfolio, as it will bring us one step closer to answering fundamental questions about our solar system and our place in it. As the Associate Administrator said, scientists believe Europa has the suitable conditions below its icy surface to support life. Those conditions are water, energy, chemistry, and stability. To do this, we will be collecting data from 9 instruments and 1 science experiment.
9.
The science includes gathering measurements of the internal ocean, mapping the surface composition and geology.
It's got an ice-penetrating radar
that may be venting from the icy crust. Sending a mission into space is hard, and Europa Clipper is no exception. This team has overcome many, many challenges. The spacecraft itself is about the size of a basketball court and is journeying into one of the most intense radiation environments in our solar system. One of
with
the
a 100-foot solar array wingspan.
Is delivering a spacecraft hardy enough to withstand the pummeling of radiation from Jupiter, but also sensitive enough to gather the measurements needed to investigate Europa's environment. Our incredible teams at NASA, JPL, and industry partners have met this very difficult challenge. We've done so head-on, ensuring Europa Clipper can survive the extreme radiation environment while still delivering incredible science to Earth. The spacecraft will be the most advanced spacecraft ever to visit Jupiter. The team has figured out a way to limit Europa Clipper's radiation exposure while still dipping in close to Europa, essentially a rinse and repeat pattern. So it's dipping through the radiation environment quickly, but gathering all the data at once.
Kind of like the Van Allen belts, except it's Jupiter, so they're much larger.
Jupiter. The team has created a vault made from titanium and aluminum that will act as a shield or armor to protect the spacecraft from the extreme radiation environment, while also dramatically slowing down the degradation of it.
Yeah, so that's really important to note. I'm pretty sure that's a fairly new. I mean, it's not like it's cool for this mission. They literally created what they said, a titanium vault, which is designed to help shield all of the internal electronics from the radiation environment. Because as we all know, radiation, all those alpha, beta, gamma particles, as they tend to hit your electronics, can quite literally not only fry your entire electronics, or at the very least can cause bit flip errors, which can cause latch ups. It can cause your system to quite literally freeze. It can create miscalculations, literally bit flip errors when a particle hits a specific point in memory, like holding a variable. Let's say that variable is supposed to be I don't know, let's call that variable 2. Well, what it can actually do is actually hit that bit that is holding that 2 value and flip it to where now it's no longer holding 2, it's holding some other number. I guess in that case it would be 0 if it flipped it in binary from 1 to 0. But yeah, and that can cause just so many different weird problems to happen. So they created a titanium vault to house all of the electronics in it to try and help reduce that radiation environment.
It's electronics. This strategy was first used with our Juno mission and was very successful. The data that Europa Clipper returns will help fill in the gaps from other NASA science missions that have studied Europa, including Juno, Galileo, and the Voyager spacecrafts. I want to thank each and every member of this incredible Europa Clipper team who made tomorrow's launch possible, as well as those who will be working with us in the coming years. I look forward to the incredible and unprecedented science that this mission is going to discover. It's, again, super, super exciting, and I want to end by saying, go Falcon Heavy, go Europa Clipper, and I'm going to turn it over to Jordan Evans, our Europa Clipper project manager from Jet Propulsion Laboratory.
Thank you very much,
Yeah,
Sandra.
most likely, Matt.
I'd like to begin by saying that the Europa Clipper spacecraft is ready for its ride into space and to gather more data than ever from a potentially habitable moon of Jupiter. Working with NASA's Launch Services Program and SpaceX, we've completed and successfully passed all of our final testing and inspections. We've closed out the remaining what we call red tag and green tag items that either get removed or before flight or installed before flight. We verified the cleanliness of the vehicle from both a contamination and a planetary protection perspective with our final assays and swabs.
It's now encapsulated
Following those
too.
activities, we closed out our thermal blankets. We performed a mechanical walk down of the vehicle prior to encapsulation into the fairing.
Isn't that
After
awesome to hear all
encapsulation
the
and transport out
processes
to the
involved?
Launch
It's
Complex
crazy,
39A,
chat.
once
Checklist,
we made it to the
checklist,
Falcon
checklist.
Heavy, we've checked out the interfaces to ensure data flows through the launch vehicle to TDRS over mission control, back to mission control at Jet Propulsion Laboratory. And at this point, we are monitoring a very well-behaved spacecraft. On launch day, our team here at Kennedy Space Center will be establishing the configuration we need to be in for launch. They'll be monitoring temperatures and verifying that all the spacecraft systems remain healthy. And meanwhile, back at JPL's Mission Control, the team will be ready for the transfer of responsibility. Once Europa Clipper launches, separates, gets acquisition of the solar array, that all happens with a single command that we say, do launch. But once that Falcon Heavy clears the tower, responsibility for Clipper moves to our team on the West Coast. That team on the West Coast, pre-launch, they're going to ensure that all of the required ground systems and deep space network stations are ready. They'll also be monitoring the spacecraft telemetry, and they'll have a test bed, which is a copy of the electronics that make up Europa Clipper, up and running in parallel to follow along with both countdown and count up. And then following separation, that team at JPL will be responsible for assessing the telemetry and state of Europa Clipper and then flying the spacecraft from then on. Separation is our first major milestone, and that's followed by acquisition signal. It takes a few minutes to warm up our amplifiers, and we'll be first looking for a carrier to see that the spacecraft is transmitting, and then followed by locking on and getting telemetry to assess the state of Europa Clipper. And then about 2 to 3 hours after acquisition of signal and Europa Clipper has had a chance to roll like a rotisserie and evenly warm up our solar array mechanisms, the spacecraft will autonomously cut the solar array restraints with thermal knives, and that process takes about 30 minutes from start to the cutting of the last one. After that, our journey to Jupiter takes about 5.5 years, and during the time we will do gravity assist at Mars. For tomorrow's launch date, that's March 1st of 2025, and then in December, gravity assist at Earth in December 2026. Then we go through a quiet cruise period, where throughout cruise, we'll be doing calibrations, periodic maintenance, and practicing our Jupiter orbit insertion and our science flybys of Europa. And then Europa Clipper arrives at the Jupiter system on April 11th, 2030.
2030, man.
Being a day
Talk about,
I must say, I'm humbled to be a part of this team that overcame the challenges
long
that come
time
from
for that
bringing a mission
return on
like Europa
investment,
Clipper
right?
to this point. I know the spacecraft and instruments are ready. I know the team is ready, and I'm at peace and confident in that readiness. And at this point, I'll turn it over to Tim Dunn, Launch Director of NASA's Launch Services Program.
Thank you, Jordan.
This one should talk about the trajectory.
I'm proud to be here today representing the women and men of NASA's Launch Services Program. I'm the NASA Launch Director for the Europa Clipper mission, and I'm thrilled to be a small part of this amazing team with the privilege of launching this flagship mission. Europa Clipper is the 10th NASA LSP mission to launch on a SpaceX rocket, and NASA's third mission to fly on the massive Falcon Heavy vehicle. Europa Clipper will launch from historic Launch Complex 39A here at Kennedy Space Center.
Yes,
Europa
yes, they are
Clipper is
NAMPs.
LSP's fourth mission from this launch pad that has previously hosted such vehicles as Saturn V and the Space Shuttle. I'd like to recognize the Falcon Heavy Europa Clipper launch team, SpaceX, NASA, the Jet Propulsion Laboratory, and the U.S. Space Force's Space Launch Delta 45. These professionals are world-class and are executing the Europa Clipper
Let's
launch
get
campaign
to some
with
of the
precision.
questions.
The entire 5 launch readiness review, followed by the joint NASA-SpaceX launch readiness review. In these reviews, we verified our range, launch vehicle, and spacecraft readiness and received approval from senior leaders from NASA, JPL,
I'm talking, Chad,
SpaceX,
the checklist that they
and
go
US
through,
Space
the
Force
procedures
to enter
are
into launch countdown tomorrow morning.
awesome. Awesome to
While
really
we
get down
successfully
deep.
fought through Hurricane Milton, our LWO, Mike McElhannon, assures me we will have exceptional weather for tomorrow's launch.
It is supposed to be a really nice day tomorrow, as far as I'm aware,
But speaking
at
of Mike,
LC-39A
I
in
want to thank
Kennedy.
him so much for his service to our Europa Clipper team.
Is traveling to the far reaches of our solar system to help us better understand the habitability of Jupiter's moon, Europa, which has one of the most promising environments in the solar system that can support the building blocks of life.
Nice.
You probably already know that at SpaceX, we're big fans of life beyond Earth. SpaceX was founded to make life multiplanetary, and we build rockets to make that dream a reality. Europa Clipper is the largest spacecraft NASA has ever developed for planetary exploration.
I know, right, Dad? You're not wrong.
1.8 billion miles from Earth, which means it needs a powerful rocket to get there. Falcon Heavy provides over 5 million pounds of thrust and will launch Europa Clipper on an Earth escape trajectory. Falcon Heavy is giving Europa Clipper its all, sending the spacecraft to the farthest destination we've ever sent, which means the mission requires the maximum performance, so we won't be
There
recovering
are,
the
Dad.
booster
I don't know
tomorrow.
if that would...
I don't know about you guys, but I can't think of a better mission.
I don't know
to
if that's
sacrifice
in
boosters for.
if that's a
But we might
need.
have an opportunity to discover life in our own solar system. How cool
Not
is
sure,
that?
you know?
The mission has been a long time coming for many, and now we're one day
So
from.
for those of you interested, so Dad was asking, you know, in terms of all of these like deep space missions, especially when Artemis comes around and all of the Artemis support missions, the Deep Space Network the network, the actual large antenna dishes that are placed around Earth in different locations for like deep space relays. Like, are they going to be over congested and whatnot? I don't necessarily think so. The only reason being is what's great about spaceflight is that for the most part, spaceflight has very slow dynamics. As you noticed, this system is going to be operating for 5 years before it even gets to Jupiter to start its science goals. So that means like, because the dynamics in space are so slow, even though things move very fast in terms of their velocity, but the dynamics are so slow that typically speaking, if you need to schedule time on DSN, right? Like, yes, you have to schedule the time, you have to pre-plan, you have to do all that. But, worst comes to worst, you just have to wait. And, your system is already in orbit. Nothing's going to necessarily impact it unless you're doing something critical. And if it's critical, then you have priority. I don't know. In the future, yes, something like that could certainly be done. Like Descom, we could actually have a outpost on the moon that has a relay network there that can go into its own deep space relay and then travel that back to Earth and stuff like that. So there's definitely a lot of ways to do that, but I don't know if that's necessary anytime too soon.
Launch. We are so excited to be part of such an amazing mission and are incredibly thankful to NASA
That's
for
a
the
good question,
opportunity.
Naps. I'm not sure about that environment.
And now over to you, Mike. You've been a little busy. Perhaps work has calmed a little bit with the winds.
Everything slows down pretty much.
Yes, we have undergone quite a transition from hurricanes, and I think next couple of days we might...
Harwood from CBS News.
CBS News, all right.
Thank you very much. I've got a couple of quick ones here. One for Tim. Can you clarify the launch window a little bit? Are you launching is the target to launch at 12:05:45, or is it more like 12:06? I was a little confused by that. And for Julianne, can you tell us a little bit about what the second stage issue was on the Crew 9 launch? Just to help me understand why we're okay to...
You guys don't remember, the whole reason why Falcon 9 was grounded and why the FAA required a mishap investigation for SpaceX was because SpaceX, per their launch license and trajectory planning for their launch vehicles, for the second stage especially, has a very specific area where they have to target in order to dispose of their second stage to make sure it doesn't land in like a populated area. And I believe it was Crew 9, right? The last mission that went up, taking the 2 astronauts up to the ISS, its upper stage missed its target. And so that triggered a mishap investigation. Falcon 9 was grounded by the FAA. Luckily, the Falcon 9, SpaceX did get a waiver for their Hera mission flight that just occurred last week. So Falcon 9 has been grounded otherwise due to that mishap. And so I guess we'll hear now what actually ended up being the cause was like a half a second too long of a burn, and that caused it to go off trajectory.
Launch Clipper. Appreciate it. Thanks.
Hey, Bill. So I will answer the window question. So, yes, as I mentioned, we have the 15-second window. It does open at Eastern Time, 12:05:45. So that is what we will be targeting. We do receive our collision avoidance report about 2 hours prior to launch. We will evaluate if we have any conjunctions or seconds in that 15-second period that we need to avoid. We'll evaluate that, at which time we want to move the targeted T0 time as late in that 15-second window as practical for the mission's trajectory. The optimal mission trajectory is actually at 12:06:00 tomorrow. So that is our plan, Bill. I know it's a little bit confusing. It's a little bit different, but think of it in terms of if you have a long window and the front half of the window is blocked by bad weather, and then you just make the decision to target the end of the window. We're doing something similar to that, but because it's easier for the launch team to prepare for the beginning of a window and then move to the right, it's very difficult to move back to the left. Julianne, I'll turn it over to you for stage 2.
Yes, thank you for the question. We often at SpaceX say we will only launch when ready, and I think what's most important is that after every experience, after every flight, we always work in partnership with NASA to make sure we're ready for the next flight. So another important note about the Crew 9 flight was that at no point were Crew 9 or the Dragon itself at risk. We had an issue on that flight during the deorbit burn, during the second burn of that second stage. During the burn, the second stage Merlin vacuum engine, or MVAC engine, continued to produce thrust for about 500 milliseconds after the shutdown was commanded on the engine. That half a second of extra thrust basically made it such that the second stage re-entered the Earth's atmosphere slightly outside of the established zone for landing of that second stage in the South Pacific Ocean.
Half a second caused that mishap.
On our vehicle, everything responded as it was intended. We basically commanded a backup Merlin vacuum shutdown process that closed the open engine's liquid oxygen bleed valve that successfully shut down the MVAC engine. The stage remained intact while still in orbit and broke up as expected. Again, it's a deorbit burn during reentry, and that took place over the Pacific Ocean. We have no known reports of debris reaching the ocean surface or damage at this time. And the SpaceX and NASA teams poured over all of this data together and have cleared the specific issue for.
So there you go. That was the confirmation.
The Europa Clipper mission is NASA authorized when we are cleared to fly for FAA licensed mission.
Because of the proximity of the Crew 9 mission to the Europa Clipper planetary window, and SpaceX brought us quickly into that anomaly resolution. We held our own independent engineering review board just the day after our flight readiness review, where we assessed and cleared Europa Clipper of this anomaly.
Sweet. Still talking about the anomaly there on the second stage.
Now we have Jeff Faust, Space News.
Hey, Jeff Faust, great journalist.
Hey, good afternoon. Question for Jordan. You mentioned that you cut the cables for the deployment of the solar arrays. How long does it take for the solar arrays to deploy and for you to know that they are all working properly? Thanks.
Did you say 30 minutes?
Yes. So it takes about 30 minutes for the spacecraft to go through all 9 per side. So it does 8 per side, and then at about 30 minutes after the initiation of solar array separation start, it cuts the 9th on either side. That occurs about 3 to 3.5 hours after launch, and it'll take a little while for us to identify the state of the vehicle following solar array separation. So launch plus roughly, you can say 3.5 hours.
It's about 30 minutes after the start.
ABC News.
3.5 hours into launch.
Yes, I'm not sure who this is for, but it's kind of a follow-up to Bill's question. Why are the launch windows so short, and do they get longer?
I'm not sure, Deadscum. I didn't hear that.
Days?
I don't think so. Oh, you meant the second stage?
So
the second stage
I'll start with that and then hand it over to Juliana.
First stage, center stage of the Falcon Heavy will be
the window remains 15 seconds for the duration of this
the 15-second window is what he's talking
that
about.
Will extend out to November 6th, so it will not change. The reason is due to the planetary nature of getting to Europa exactly when we want to. So Juliana, I'll let you pick up there.
Yeah, they call it rocket science for a reason. It takes a very, very specific trajectory. We have to deploy the payload exactly to the time and place it needs to be to continue on its journey flying by Mars on its way to Jupiter. And so for that reason, we keep
it's pretty tight margins,
as possible, so the spacecraft team knows exactly where their spacecraft is, when and where when we deploy them. And we do, oftentimes, a lot of our missions actually have instantaneous windows, like Dragon.
Yeah, SpaceX does a lot of instantaneous windows. They do have certain flights that also go, farther out and have an hour launch window or whatnot. I do wonder, just out of curiosity, Vulcan and Atlas V, ULA's rockets, typically can have much larger flight window opportunities and less having to do instantaneous flight windows because they have their upper stage, especially their Centaur, is really, really high energy capable, like really efficient, right? Like its ISP is like 480 seconds because it's a hydrolock system. So really, really efficient upper stage. And that allows them to, have a, they basically have a lot more room for error that they can then, push out that flight window. So I do wonder if this actually flew on Vulcan, or let's even say like Atlas V, if their flight window would possibly be a lot larger. Just out of curiosity.
Missions, but for this mission, we made sure to keep at least 15 seconds to support a COLA, or risk of collision, essentially, for an on-orbit asset. So we have that 15-second window to play with, and that I'm sure will be good for any COLA issues. Right, thank you. Next, Will Robinson,
Naps.
Space Flight Now.
Centaur is amazing.
Hi, thanks, Megan, and thanks everyone for taking the time. Question for Tim Dunn, and then a quick follow-up, if I could. With the launch date, can you explain why the launch pushed forward a day and it was pushed back about 24 hours? And then I suppose another one that would also go to Tim just very quickly. There appears to be a Falcon 9 Starlink launch also on the schedule for tomorrow in the early morning overnight hours. Is NASA still requiring a 24-hour stand down from Starlink launches ahead of NASA missions, or is SpaceX able to move forward with the Starlink launch and then have Europa Clipper follow it up some number of hours later? Thanks.
Yeah, let's see.
Hey, Will. I'll start, and again, I'll hand over to Juliana.
So that Starlink mission was pushed.
Question and answer. So on the separation that you're asking about Starlinks, due to the importance of our NASA LSP missions and the level of mission assurance that we desire into it, we have always requested and worked with SpaceX to have a setback
that's right,
from their prior Falcon mission prior to a NASA LSP mission.
Yeah.
It has varied through the years. We started somewhere around 72 hours a few years ago, and we've been working to get that down as low as possible. Given the nature of Europa Clipper flying on a Falcon Heavy, obviously there's 3 times the booster data that has to be evaluated on that flight, and so it takes resources from our team that need to commit themselves to be ready for Clipper. And so we actually needed SpaceX to set a 48-hour standoff from the Clipper launch time to when they would launch their previous Starlink or other commercial or even a Space Force or NRO mission. So
interesting.
SpaceX has been very accommodating, working with that special
even
request
over
that we
NRO.
have to
That's
allow
interesting.
our teams to look at that prior launch data to give us
You'd
the
think military
maximum
might have a little
assurance
bit
that there were no flight
precedence.
anomalies prior to us committing to the Europa Clipper launch in this instance. So, for instance, you may see a Starlink mission is being moved as we speak on the range schedule from early tomorrow morning to what would be early Tuesday morning.
Yeah,
after
that's the one that got
launches.
moved.
And so SpaceX maintains the capability should we have run into something during our reviews today where we needed to move
NRO is
to
the
the
National
right
Reconnaissance
a handful
Office,
of days,
military.
they would be in a
SpaceX.
readiness posture to launch that Starlink mission later this evening, now that they've received FAA clearance coming out of the Crew 9 anomaly. So that is
Nice.
that explains the setback there. Juliana, I'll let you take the.
Well, I think I'm going to pause it there, chat, because it's getting late, and I definitely do want to get into our helicopter adventures in KSP. So I'm going to post the rest of this Europa Clipper teleconference here. From my understanding, there wasn't too much, because I did read the transcript earlier, there wasn't too much information divulged other than hearing confirmation about the Crew 9 anomaly on the upper stage of Falcon 9 that caused the mishap. We got that confirmation as to what occurred. But everything else seems pretty good. So Europa Clipper, like I said, is scheduled here to launch at 10:06 a.m. Mountain Time. That's 12:06 p.m. Eastern Time. So that will be launching Falcon Heavy. We're getting treated by SpaceX this weekend, chat. It's gonna be great. But yeah, so Falcon Heavy, pretty solid. So with that, chat, I'm going to kick us over here into this one. No, not this one. This one, yes. I'm going to go ahead and close out on the thousands of tabs that I have open here for today's Go No Go poll news segment. We are going to switch things over into some Kerbal Space Program. In the meantime, like I said, I hope you guys enjoyed that little bit of space news. I'm definitely going to try to do more of that here and there. Next one will probably be on Wednesday, and maybe we'll be able to stream the launch tomorrow. I'm not sure. That's kind of up in the air because of work and things like that. So yes, in the meantime, Chad, let's switch things over into some Kerbal Space Program. What do you say? What do you say, Chad? If you were here for the space news, I hope you guys enjoyed it. We're going to kick things off into a game called Kerbal Space Program. And let me see what I can do on the Twitch side. I am probably going to, sorry, not on the Twitch side, on the YouTube side. I think, and actually, let me see, stand by. I'm trying to remember how I did this before. If there's like a way to end the YouTube stream, change the title, and redo it. We'll see here. We'll see. Yes, I think there is. So I'm going to end the YouTube stream so that way we can cut this segment of Go No Go Poll news. And then I'm also going to run a little ad break in between here since we're going to be switching games, and that way we can get rid of all of the Twitch ads. So on Twitch side, I'm going to run some ads. And I'll see you all back here momentarily as soon as I can get all of this figured out. So see you guys here in a moment. Alrighty then, let us see what we can do.